wherever the camera is. I'm David, and this is the second, possibly third. Anyway, this is a seminar about the fundamentals, and today's is about the rules that numbers work by, and therefore the rules that algebra works by. And so I'm going to talk about rearranging calculations and then rearranging expressions, because the only reason that algebra works the way it does is because numbers do. And so that's what I'm going to talk about. And hopefully you'll learn some of the rules of things that you are and are not allowed to do to numbers, and therefore things you are and are not allowed to do with algebra. And that's what today's is about. So I'm just going to walk off camera and talk about this. So what I'm going to do is I'm going to build it up from the simplest kinds of operations that you can do on numbers, and eventually get to the more complex ones. So the first thing I'm going to do, if you just give me a couple of seconds to sort my stuff, is to just get some numbers. Three will do. And to have 6 plus 3 plus 4. Look, with numbers with plus, plus is the simplest kind of thing that you can do to numbers. And it's the most flexible. Addition is very flexible. It makes not the slightest difference what order you put the numbers in. It'll always come to the same answer. This comes to 13. But I could just as easily do 6 plus 4 plus 3 and it would still come to 13. Or 3 plus 4 plus 6 and it would still come to 13. Doesn't make any difference. So if it's all just plus, I can do it in whatever order I want and it'll still come to the same answer. I don't even have to do it from left to right. I could do 4 plus 6 comes to 10 and then plus 3. Doesn't matter. I can do whatever I want and it'll still come to the same answer. And even if I don't calculate what that comes out to, I can know that it comes out to the same answer even if I don't calculate it, just because the rules of plus means that I can arrange however I want. So I'm going to write that down as my first rule. If it's all plus, then you can do it in any order you like. These are not going to be grammatical sentences, by the way. So that's my rule number 1. All right. So the next sort of operation I could do is I could do subtraction as well. Back to the camera. So that was 13 so far. Minus 2 would make it 11, and minus a 9 would make it 2. Okay, so far this calculation comes out to be 2. And when you learn the order of operations, as this is called, or BEDMAS or BODMAS or whatever you've learned it as at school, you will have learned that you're supposed to do addition and subtraction in the order they come from left to right. But that's not completely necessary, right? As long as the minuses are still attached to the things they were attached to before, you can do it in whatever order you want. So I could just as easily switch them round and it'd be fine. Okay? And it would still come to the same answer. I could just as easily do that and it would still be the same answer. Okay, because the minus is still attached to the 2 and it was attached to the 2 before, it'll still come to the same answer. So I can rearrange this expression in whatever order I want as long as the things that had the minus before still have a minus. So it's almost as if those minuses attach themselves to the numbers they're next to. And it doesn't even matter if it ends up out the front I can just starting with the number minus 2. If I put it over here, I'll just need another plus. Oops, I'll have to move everything over, or move my camera. So you can put your numbers right at the front if you want to. I think I might have run out of pluses. Nope. As long as that just means that you're starting with a number called minus 2. And these will all come to the same answer. So you can rearrange however you like, as long as the minuses are still attached to the things they were attached to before. So that's my rule number 2. If there are minuses, rearrange. As long as the minus stays with its number. The point I'm trying to make is that I could take my calculator and ask it to calculate that, and they would always come to the same answer. The reason you would be interested in doing that is because by rearranging it into a different order, it might be easier to do the calculation. Okay? It's much easier. It's much easier to do this calculation by grouping the 4 and the 6 together to make 10, because I can do 10 in my head, and putting the 3 minus 2, because that comes out to 1. So I've got 1 and 10, and look, even better, 10 minus 9 is 1. So this bit here is 10 minus 9, which is 1. This bit here is 1, so I have 1 plus 1, so it comes out as 2. So rearranging it in a different order makes it easier to perform the calculation. And you might see some of the lecturers or tutors or anyone that you've seen working on maths do this sort of thing, to add it up in a different order so that it's easier for them to do the calculation. Okay. So that's the rules for plus and minus, if all we've got is plus and minus. I haven't even gone into the world where there exist timeses and divides yet. But if there is pluses and minuses, I can rearrange it in whatever order I want, as long as the minus stays with its number. Okay. Now, at this stage, I'm going to introduce some brackets. Brackets will change which thing has to be done first. Brackets are designed to hold things together. Okay, so at the moment it doesn't matter what order I do it in, except that the minus has to belong to this 2. Okay, so since I don't have to do it in any particular order, I could add brackets in most places and not change what the answer comes out to. So I could do this. And tell the reader that I'm really interested in doing 4 plus 6 before I do everything else, but there's no particular reason to. It's all just plus and minus, so those brackets there are irrelevant. But I will say that this will be a different answer. If I put my brackets there, if I put my brackets there, then that I have to do the 2 plus 4 first, and then I have to minus it. So this will be a different answer. If we look at this, I'll have 2 plus 4 will be 6. I'll have 3 minus 6 and then plus 6. So minus 6 and then plus 6 would come out as 0, and I have 3 minus 9. So my answer would be minus 6, whereas before it was 13. So, no it wasn't, it was 2 before. So it was 2 before, and now it's something different. So what I'm trying to point out is that brackets can force the answer to be different because it's telling me that I have to do the plus before the minus. It's telling me that this minus belongs to the whole of that expression there. And so there's nothing that I can do other than add that first. But in fact, there is something I can do. Okay? I can rearrange this in a different order if I want. It's just that these brackets here are holding all of this stuff together. With my magical blue tack, these brackets are holding this whole thing together. So I can move that thing as a whole. I could very easily calculate, sorry, the minus is still attached to that. Minuses stay attached to whatever they were attached to. That's an important thing to note. I should have done that. Just a second. And I can do this if I prefer. And I could just as easily do this if I wanted, because the minus is still attached to the 9, it's still attached to that bracket, and it would still come to the same answer. Those brackets are holding those things together so that they will move as one object. So what I'm trying to do is that in my head, is tell you what's going on in my head. In my head, I have objects that are moving around on the page, so that the answer doesn't change, but if I move it around in that way, it will be easier to calculate. Look at this. 9 minus 9 is 0, so the answer must come out to whatever that is, which is minus 6. Okay? There's no particular reason why I would do that today, but if I happen to notice that a bit added up to 9 and I'm subtracting 9 later, that's okay. Point is that the brackets is forcing all of that to move together as one object when I move it around. Right. So that rule that I said before still applies. So I am going to write it down, but it applies to things with brackets too. So brackets groups things together so that they move together. Right. There is something I can do with the brackets that allows me to rearrange this and write it differently, and I will show you what that is. This minus 2 plus 4 is the same as a minus 6. The 2 plus 4 is really 6, and so it's the same as minus 6. But I could achieve subtracting 6 by subtracting 2 and then subtracting 4. So if you see a minus outside of a bracket and there's pluses on the inside, then this minus can come in and attach itself to both of these things separately. So I can break my brackets and say I'm actually going to break apart this fact that this bracket is holding things together. And if I want to do that, then this minus is going to attach itself to both the 2 and the 4. Those brackets are meaning that the minus belongs to both of them, so that's what I'll do. I will actually say, well, the minus belongs to both of them. So the minus will clone itself and attach itself to both numbers. And that's the same answer. Okay? So minus 2 minus 4 came out to the same answer as minus 2 plus 4. I'm actually going to write that down on the paper so that it's written properly, so that it can be recorded. So minus goes in brackets where there's plus. This only works if it's all plus inside the brackets. So here's my example. So 6 minus 9 minus 2 plus 4. That's the same as 6 minus 9 minus 6, but I could just as easily say, well, this is the same as that. So the minus clones itself and attaches itself to both of these numbers in here. And you can't see that at all, can you? Okay, it attaches itself to both of those numbers. And I haven't really done anything. The answer is still the same as it was before. It's just written differently. Okay? The reason to write it differently would be to try and find a better way of calculating it. At the moment, it would have been better to leave it as it was. But I'm just trying to point out the rules that numbers live by. I can rearrange numbers and not change the answer, because numbers are very flexible things. Okay, so now I've dealt with plus and minus and how minus interacts with brackets. The only thing I do need to point out with is what happens if there's a minus inside the bracket when I bring a minus in like that. And I won't do it on my whiteboard, but I will do it here. So minus will go inside the plus. It'll go inside if it's all plus and minus in there. It's just that you'll get an extra minus. So the other thing is that minus minus is the same as plus. So just as an example, if I combine those two rules together, 5 minus 2 minus 3. 2 minus 3 is the number -1. And 5 minus 2 minus 3 is the same as 5 minus 2 minus minus 3. So the minus came in and attached itself to the 2 and it attached itself to the 3, but there was already a minus. So the minus minus is the same as a plus. Okay, so those operations there, every single one of those things represents the same number. It's all the number 4. No, just a second. 6. That's all the same as the number 6. I could have, if I wanted to, calculated it differently. It would have been much better to do it this way. 2 minus 3 is -1. And look, minus minus 1 is plus 1. The same rule I used there as well. Minus minus 1 is the same as plus 1. So this really is the number 6. Okay. I hope I'm making the point. I keep saying it over and over, but it's really important. This is just about rearranging things so that they look different. Okay? All of these, the goal here is not really to calculate anything. The goal is just to have different names for the same numbers. All of these things that I've written on the page here are all just different names for the number 6. At any point where I see the number 6, I could, if I wanted to, it would not be a good idea, but I could, if I wanted to, replace it with any of those things. Okay? Usually you would like to replace it with something useful. This isn't useful. But knowing that 6 is 5 plus 1 helps you when you say, well, 9 plus 6, well, that's the same as 9 plus 1 plus 5, which is 10 plus 5, which is 15. Okay, and that's in fact how you begin to learn about adding numbers that are near 9 and what it means when you're carrying things, when you're doing ordinary addition and subtraction on paper. Okay, so far, let's just look at the rules we've seen so far. If everything's plus, any order is fine. If there was a minus and there's pluses as well, then you can rearrange it as long as the minuses stay with what they were with before. Brackets group things so that they move together. Minus goes inside numbers in those boxes. Inside something with pluses, and it attaches itself to each number. And if it attaches itself to a number that's already got a minus, then minus minus is the same as plus. And I should point out that you don't just need 2 numbers there, you can have as many numbers as you want. Okay? It could be 2 plus 3 plus 5 plus 7, and they'd all get a minus. Okay. And now we're finally up to what happens with times. So if it was all times and there wasn't any plus or minus, it was just times, what would happen then? how could I rearrange something that involved timeses? I'll let you think about that while I fiddle with my Okay, so is anyone going to volunteer a piece of information about how times works? How could I rearrange that? If it's all times, I don't even need to know what that is. That's a horrifying number. Do not like it at all. Let's just think a second. 3 times 9 would be 27, times 2 would be 54, times 6 would be, oh God, 324, I think. Yes, 18 times 18, whatever that is. Which is why I brought a calculator. 324, I was right. Okay, so the thing is that you might have noticed that when I said the words to calculate this, I didn't do it in the order it was presented. Times can be done in whatever order you want. Okay, as long as it's all times, you can do it in whatever order you want. And what someone just there said, well, the 3 times 6, that's 18, I can do that bit. And the 9 times 2, that's 18, so we get 18 times 18. So I can do it in whatever order I want. I can rearrange them around a different way. You know, I could do that if I wanted. Three times 2 times 9 times 6. If I desired, it might even be better to do that. 3 times 2 times 6 times 9. And then I'll have 6 times 6, which is 36. And then hopefully doing it times 9 I could do. Okay, so that's times. If it's all times, I can do it in whatever order I want. If it's all times, then any order is okay. You can do it in whatever order you want. You can do the bit in the middle and then times something else and then times something else. You can rearrange it however you like. What if it's times and some divides? Just going to make a different expression that is a different answer. Your classic order of operations tells you that you're supposed to do timeses and divides in the order that they come. You're supposed to do 9 divided by 2, which is 4.5, times 6, which would be 24, it's 27, and then divide by 3, which would be 9. Okay, but that's not necessary at all. How do you think I'm allowed to rearrange things with timeses and divides? I can change the order. Could I do this? Would that be okay and still give me the same answer?
No, it's not the same.
So I can't switch around. I can't switch around if they're attached by a divide. It's the same rule as it is for plus and minus. If I rearrange pluses and minuses, the minuses have to stay with the things that they were with. Same deal with times and divide. If I'm going to rearrange things that are all times and divide, the divides have to stay attached to the things that they were attached to before. I can divide by that 3 whenever I want. Okay? It doesn't have to happen at the end, it could happen at the beginning. So it is a divide by 3 at some point. I could divide by 3 first. And have 9 divided by 3. Just move it all over. And that would be better. 9 divided by 3 is 3. Oh, even better, why don't I divide by the 2 later? 9 divided by 3 is 3. 6 divided by 2 is 3. I'll have 3 times 3, which is 9. So it doesn't matter what order you divide things in, multiply and divide things in, as long as the things which were divided are still divided after. Even better, that order would be way easier to calculate. 6 divided by 2, then divided by 3 would give me 1. 1 times 9 is 9. Okay? So the key is, it works the same as its plus and minus worked. Okay, when it was all plus and minus, I could rearrange however I wanted as long as the minuses were still attached to the things they were attached to before. If it's all times and divide, I can rearrange as long as the divide is attached to whatever it was attached to before. If it's all times and divide, in any order as long but do remember, it's worth pointing out, I will do as an example. So what did we have? 9 divided by 2 divided by 3, I could just as easily go, well, and move the whole divided by 2 over there. And I could move the 9 to the end if I really wanted. Okay? Right. So we've got this idea that plus and minus are related to each other, and times and divide are related to each other in the same way. Okay? If it's all plus and minus, cool. If it's all times and divide, it'll behave in the same way. The next stage is to see, well, what happens if there's plus, minus, times and divide all together? Okay. So all the same rules are going to apply. It's just that in the same way that brackets hold things together, the times and divides are going to hold things together. So if you've got all of them, then times and divide hold things together like brackets. In fact, you're supposed to do the times and divide first before you do the plus and minus. Okay? So there's two things there, two bits of information. You're supposed to do the times and divide before you do the plus and minus if you're going to attempt to calculate something. And if you're just going to rearrange things without calculating them, the times and divide hold things together like glue, or blue tack, as it were. So here we go. Let's put some pluses back. I'll leave my divided by 2. So that one there, the 6 divided by 2 is attached together, okay? And the 9 times 3 is attached together. And I might put another number in there. If I was going to calculate that, I would have to do the times and the divides before I did the pluses and the minus, the pluses. Okay? So it's almost as if I glued them together, well, blue tacked them together, they're glued together by this divide sign, and these two are glued together by their times sign. Okay? So I can rearrange this in any order I like as long as the things that are multiplied together move together. So I can do this if I want. Okay? That whole thing that's attached with the times belongs together because it has to be done first, no matter when I do it. Times has to be done before plus. That 9 times 3 has to become a 27 no matter when I do it. Okay? So since this is really 27, and if this was the number 27, I could do the addition in whatever order I wanted. I can move it together without even calculating it. So this is really the number 27, and I have to figure out what that number is before I do the plus, so I can put it wherever I want. Okay? And this 6 divided by 2 is really the number 3, and I'm not allowed to add it to anything until I've calculated it anyway, so I can move it where I want, as long as it stays together. Okay? So if I had to calculate this, I would be forced to do this one and this one before I did the plus. But that means that I can move them before I calculate them, since I have to do them first anyway. Okay, so I'm going to do 2 examples there. One of the bit where you actually calculate it, and one of moving it around. Nine times 3 plus 6 divided by 2 plus 5. The rules say that times and divide has to be done before plus and minus. It's an example. So this would be 27 and 2 and 5, which would come out to whatever it comes out to. I suppose 27 plus 7 would be 34. Okay, that comes out to 34. But I could just as easily have gone, oh, well, that's the same as this. If I wanted. The things that were multiplied move together as a block, because I'm going to have to figure them out anyway.
Excuse me.
Yep.
I think that's 27 plus 3.
Oh, yes, you're right. Thank you. 6 divided by 2 is totally not 2. Thank you. Which would be 35 then. Right. Thank you. Okay, and this is still 35, even without me calculating it. So that order of operations that you learned that said that you had to do multiplication before plus also tells you that you can rearrange things as long as the times things are glued together. And so we can now learn another example. That one there. I can rearrange within this block. If I just look at that bit, I can rearrange within that in whatever order I want, as long as the divide stays with the 2. And I can rearrange within this block however I want before I do the calculation. Because remember, I can rearrange times and divides. As long as this divide 2 doesn't cross the plus, as long as it stays inside its block, I can rearrange it like that. So it would be way easier to go, oh look, 2 divided by 2 would come out to 1, so this answer must be 3. And 8 divided by 2 would be 4, so this is the same as 5 times 4. So I've skipped several steps there and I'm going to write them in. I could just as easily go, well, 2 divided by 2 times 3 and 5 times 8 divided by 2. So 2 divided by 2 is 1, 1 times 3 is 3, 8 divided by 2 is 4. So I get 3 plus 20 plus 1, which is 24. So the key part of rearranging is that it makes it easier to do calculations. It's much easier to do 2 divided by 2 than 6 divided by 2, because 2 divided by 2 is just 1. And it's much easier to do 8 divided by 2 than 5 divided by 2, because that gives me nice whole numbers. Now, to be fair, most of the time when you really need to do this, it's all like crazy decimals or something. But it still means that you can now start to do things a little quicker by rearranging a little. Okay, so we have times, we have divide, we have plus, we have minus. We dealt with minus and brackets. We're just going to have to deal with the times and plus and minus and brackets as well. Okay. So So if you have, now how did I say this? Some number times goes inside a bracket with a plus, the same way that minus did. Okay? This is called the distributive law, in case you've ever seen it written anywhere, and in case you want to look it up on the internet. It's called the distributive laws because, well, it's actually not quite the way that we use distribution in ordinary English. In ordinary English, when you distribute something, you share it out. So you would imagine that if this was a 3 times, you would share it about among the others, but you don't. You copy it and it goes into the others. So it's like it's being cloned, which is what I like to call it. And you do this every time you multiply 2-digit numbers. Okay? So when I do 5 times 12, you might know what 5 times 12 is. But if you didn't, you go, well, 5 times 12 is the same as 5 times 10 and 5 times 2. So the rule, so we're just doing what we know we're allowed to do. The 5 times will attach itself to both. Well, 50 plus 10, getting ahead of myself. Okay? So this rule, this distributive law, says that if I have a times outside a bracket and a plus inside, I can bring the times in and clone the number that was with the times. It works on both the left side and the right side. It works even if there's a minus as well. So the 2 will attach itself to both the 5 and the 8. And it won't change what the answer is. Now, to be fair with this one, it was easier to calculate it beforehand. It's probably easier to calculate it as like minus 3 times 2. But with some things, if you're going to do it mentally, it's easier to do it a different way. Just like with my 5 times 12, it was easier to split the 12 into the 10 and the 2 and times the 5 separately. Okay, and those distributive laws apply to several things, but almost never apply to anything else. So I'm just going to write them. Just a second. Yep. So with divide, divide will go inside as well, but only if it's on the right-hand side. Okay? (10 plus 5 divided by 5). I could just as easily go 10 divided by 5 and separately 5 divided by 5, which gives me 2 plus 1, which is 3. Okay? I can divide them separately. The divided by 5 went in and belonged to both of them. But it won't work the other way round. It will not work if you have the divide on the other side. Nothing we can do. There is no hope, there is no way of rearranging that. Other than just simply going 2 plus 3 and that's 5, and 12 divided by 5 is whatever it is. Okay? You cannot bring a divide in if it's on the other side. It only works on the right-hand side. Because divide is different on the two sides. 6 divided by 3 is not the same as 3 divided by 6. Okay, so that's really important to know. And the other thing, so we know that minus, just a single minus sign goes inside my brackets if it's all plus and minus in between. A times will go inside whether on the left or the right. A divide will only go inside on the right-hand side. Right. doing well. So the distributive laws allow you to split things up, separate them out, fiddle and join this to this, and when people do these calculations, that's what happens, okay? They're going, well, if I split this apart, I can join it to that, and I can do that bit, and then I can join this to that bit and do that bit, and then join them together after. And there's a whole lot that's going on where where a person doing these calculations in their head will be moving and combining things. And that's the whole philosophy of algebra, is that even if I didn't know what the numbers were, I could still do this, okay? Should have brought a whiteboard marker. Even if I didn't know that this was the number 5 and it was a missing number, I could still use these same rules. Okay? If it was written like this, whoa. If it was written like this, and I felt that I had to do this left to right, even though I didn't know what that number was, I'd feel trapped. I could go, well, 27, and then plus something, and then I'd have to add 6, then I'd have to add 3. But I couldn't do it because I wouldn't know what this was. But the power of being able to rearrange things says that if I rearranged it, I could figure out as much as I could do without worrying about the thing I didn't know. So when we do algebra and we call this x or something, the whole point of this rearranging thing is to calculate as much as you can without knowing this number. So if you were forced to do it left to right, like your traditional BODMAS or order operations tells you, then you wouldn't be able to do anything. But if you are capable of rearranging it, then you can do a lot more stuff and make it look simpler so that when you do eventually find out what this number is, you will be able to calculate it quicker in the end. And it also means that next week when we solve equations, it will allow us to actually figure out what x is by doing as many calculations as we can before we deal with the missing number itself. Okay, so I do have one last thing to show you, which is to do with powers. And that will give me my last 5 minutes. Okay. So there'll be a whole seminar on powers and logs, but I'm just going to do a little bit here. Powers. I will do some of the other types of powers later. So if I don't mention all the half powers and things like that, please don't be offended. But 3 to the power of 5, that's how that's pronounced, is the same as 3 times 3 times 3. Okay, the same as taking 5 3s and multiplying them all instead of adding them. That's what those powers mean. And there is a rule that says that 3 to the power of 1 is just 3. It's just 1 3. It's not multiplied by anything because there's only one of them. Okay? So they're the basic laws of powers. There are other laws which I will do in a later seminar, but these ones will do. And powers are the next level up from times. So you can imagine that when you first learned about multiplication, you first learned about 3 times 2, meaning 3 lots of 2, or 3 groups with 2 things in them, you would think, all right, well that's just 2 plus 2 plus 2. And that would be a way of calculating multiplication. Technically, multiplication isn't just repeated addition, it's even better than that, does all sorts of cool stuff. But when I did 3 times 2, it's the same as 2 plus 2 plus 2. All right? Same deal. 3 to the power of 5 is 3 times 3 times 3 times 3 times 3. Right, yep. So it's the same, it's a next level up. Times is the next level up from plus. Powers is the next level up from times. And what that means is that powers relates to times in the same way that times relates to plus. And I'll show you what I mean by that. Okay, so powers is the next level up. So that's my definitions. So if you have an expression that has powers and times in it, then there are things that can be done. So the first rule is that powers have to be done before times and divide. Okay, powers must be done before times and divide. Okay, so if I had this, put my 5 back. If I had my 5 to the power of 3, also pronounced as 5 cubed, that would have to be done before divide and times, but divide and times have to be done before plus, so I would have to do this before I did that plus. And if my power of 3 was, this answer of rearranging that I'm doing is not valid, but if my power of 3 was here, I would have to do that 3 to the power of 3 before I did the times. Okay, it's not 9 times 3 and then 27 then to the power of 3, it's 3 to the power of 3 then times 9. Okay, so powers have to be done before times, they have to be done before divide. So if I take this expression and I think about that, that means that since powers have to be done before times, this whole object here is a block that has to be, if I'm going to move it, it has to move together. Okay, just like when I did times had to be done before plus, which meant that it glued things together and I had to move them together. Well, this power is going to have to be moved together. But the glue that sticks it together is stronger than the glue that sticks together the times and divide. So it's not just glue tack, it's sticky tape. Okay, so this has to be moved together. I can't separate it to move the power away. I could do this if I wanted. And I could switch these over. All right. And that would be perfectly fine because the power has to be done first. As long as the power goes with the number that it's attached to, you'll all be fine. But I could just as easily move the whole thing because it's all glued together with the times. Okay? So powers follow, when you want to rearrange things, powers follow along with the number they're attached to. So if you're rearranging with powers, powers stay with the number that they're on. So my example that went with that was I had like 5 plus 3 cubed times 9. Well, that's the same as 5 plus 9 times 3 cubed. And the cubed is it's attached to the 3, so if I'm going to move this, I can move all of it, but it will come along with the 3 that it is attached to. Okay? Because it has to be done first. So since the powers have to be done first, they have to go with the things that they have to be done first with. So if I'm allowed to rearrange times to wherever I want, as long as they're all attached together, well, the power will have to go too because it has to be done before the times. Right, one last rule. We've got about a minute to go. Right, we have got brackets. We've dealt with minus and plus and brackets. We've dealt with times and divide and minus and plus and brackets. Powers and brackets. What's that going to do? Powers go into brackets with times, okay? Attaching to each number. It's the distributive law again. It's just that the powers, instead of having a plus in times the brackets, I've got a times. So it's cloning again. 2 times 3 squared, power of 2 means squared, is the same as the power coming in and attaching itself to both of them. And it works with divide as well. Okay, it works just as well with divide. Now, totally, 6 to the 5 divided by 2 to the 5 is way less simple than 6 divided by 2 then to the 5. But the thing is that if I didn't know that one of them was a 2 and it was just an x, then it might help. Okay. What powers don't do is come in over a bracket that's got a plus in it. Okay, powers don't go into there, you've got nothing you can do. We can't do anything. Technically, we can, because there's a whole separate rule, but I'm not going to get into that. So, powers do not come in over plus. And this is how I remember it. Okay, I'm going to do my little memory tool to remember all of these things. I'm going to start from the bottom and work my way up. First, we had plus and minus. Plus was the most flexible. You could do anything you want with plus. Rearrange it however you like, it'll come to the same answer. Minus was slightly less flexible. We could move things around as long as the minus was attached to whatever it was attached to before. The next layer up is times and divide. So times was a whole lot of plus, and so it's the next layer up. And when I did my distributing, moving over brackets, the times was able to come in over brackets that involved plus. It was able to come in over brackets that involved minus. So was divide, but it was less flexible. Okay, so we have more flexible here. Okay, I was able to rearrange at this level. If everything's at that level, I'm able to move things around however they want, but the divide has to stay attached to whatever it was attached to. And this way, I can go into my brackets. But again, going into brackets, with my divide, the brackets, it could only work on one side. And then the next level is powers. And in a calculator, you write powers with a little caret like that. Or in Excel, for example. And powers are able to go out over times, but they do not go in over brackets involving plus, because the plus is too far away. It's only the next one down. And I should say that roots work the same way. Roots are able to go in over times and divide, but they're not able to go in over plus and minus because the plus and minus is too far away. And this also tells me the order that I have to do things in. Like the granddaddy of them all is brackets, which holds things together. So this is both the order of operations, which some people know as BODMAS or BEDMAS. This is both the order of operations and the distributive law. Okay? If I'm going to do a calculation and I'm just going to do it straight the way it's written, times, then powers, this works like brackets does, so that's a bit of a special case. Times, then powers, then times and, brackets, then powers, then times and divide, then plus and minus. And if I'm going to expand out brackets and distribute things, this will go in over that, these will go in over that. That's my little way of remembering it. And it works for me, and I hate acronyms because I can never remember them. So that's why I use that one. Okay, that was my rules of calculations. And I only mentioned algebra once, and so I may actually mix up my seminars a little after the break. But I only mentioned algebra once. And the point is that it works the same whether they're letters or numbers. I can move things around whatever way I want according to these rules, and it still represents the same thing. Cool. Thank you very much. I'll see you around.